Now let's take a look at the third type of FRQ, a graph analysis. Now when you're doing these type of problems, typically you will be given a graph of the derivative. This is called a graph stem. Now, I say that to only say that sometimes you are actually given an algebraic stem and you have to be able to analyze everything from it algebraically. I'll show you an example of each one. Let's see, so many times if it's a graph stem, you're not given an equation. You have to really determine the important features. For example, critical points, maximums, minimums, increasing, decreasing, so forth. And so as I just said, extreme values, increasing, decreasing, concavity. So this is basically your first and second derivative test. If you remember that one resource page where it was like the bubbles that kind of told you about everything, that's the resource page you'd want to look at. Now, many times it is given in context of a situation like velocity, and this would be similar to the last FRQ, motion, that we just reviewed. Now, what do you need to be able to do? Well, you need to be able to use your derivative techniques, for example, finding when the first derivative is equal to 0, and then many times you will be given an expression that is an integral, and you'll have to take the antiderivative to be able to find values of a function. For example, if you're told that g of x is equal to the integral of 0 to x of f of t dt, you'd have to, if you need to find the value at 4 for g, you'd have to use your antiderivative techniques and plug in 4 for x and use the graph to help you find that solution, okay? Extreme values, and then fundamental theorem, which is exactly what I was just showing you here. And then the fundamental theorem, understanding that the derivative of g of x is actually the graph of f. So if you're given the graph of f, understanding that it is the derivative of g. And last of all, remember, even if they don't ask for it, you must show your work and explain all solutions. So let's take a look at our first example. This is very typical. It is a no calculator. Notice you're given a graph of f, and you're told that g of x is the integral from 2 to x of f. So immediately the very first thing I would do is f is equivalent to the derivative of g. That way I can talk about when g is increasing, decreasing, concavity, extremes, and such. Now would you please on a piece of paper answer A through D in pencil, showing all of your work. Do not leave anything blank. You know everything at this point. Okay, so here is the FRQ rubric for letter A and B. First of all, as I said in the beginning, if you labeled somewhere that the derivative of g is f of x, and you apply that in A, if somewhere in A, B, C, or D you wrote that, you get 1 point. So look at your work. Did you write that somewhere? Okay, letter A. You get 1 point if your answer with justification is correct. So you said it's neither a max or min, and then you justified it because saying that, of course, the derivative of g is f, and at that point the sign of f does not change. Let's see, for part B, you had to give your answer with justification, saying that it's a point of inflection at x equals 4, because we know that the slope of, the derivative of g changes from positive to negative at x equals 4. So the slope of g prime, so in other words, the second derivative. And then here are the answers for C and D. Now C, you're asked to find absolute minimums and maximums. So for absolute minimums and maximums, you must consider the endpoints, and you must find those values by actually plugging those values into the function and evaluating. And you can see here the order of the limits is incorrect, so you had to take the opposite of whatever answer. And then you must find the values of the critical points. This is your justification, finding those values. So you consider the critical points, you consider the endpoints, and then you come up with the correct answers with justification. Notice this is worth 2 points. You do not get partial credit. You cannot get 1 point if you get one right. You have to get both right with justifications. And last of all, you're asking for when g of x is less than or equal to 0. So you look at the graph, and at these two intervals, that is when the derivative of g is less than 0. So g of x then is decreasing. So score yourself toughly. What was your score on this first FRQ? And what were your weaknesses or mistakes in doing this? Now your next FRQ that I've given you, notice this time I gave you an FRQ that has an algebraic stem. But I'm going to ask you pretty much a lot of the similar questions, some a little different. And so this is a no calculator question. You notice it's a piecewise function, and then you've got 3 parts. So go ahead and answer this on your piece of paper in pencil, showing all work. Okay, for letter A, asking if it's continuous. Notice here I show all of the justifications for continuity. So first of all, does the limit exist from the left and the right? I show that work. Does the value exist at 0? I show that answer. And then I state clearly that the value is equivalent to the limit. Therefore, f is continuous. In order to get your 2 points, you must prove all 3 conditions of continuity. Secondly, you're asked for the derivative and finding out when the derivative would be equal to -3. Well, the derivative of the first piece is -2 cosine. And you know from your graph of cosine x with an amplitude of 2 that it would never reach -3. And you know that just because you know your functions well enough. Now you look at the second piece and you look at the derivative, set it equal to -3, and now solve for x. And you get -1/4 natural log of 3/4. And therefore, that is when the derivative would be equal to -3. And last of all, you are asked to find the average value from -1 to 1. Well, first thing you need to realize is that you have to basically set up 2 different integrals. The first piece of the function and then the second piece of the function. So notice that is worth 1 point. And then you have to take their antiderivatives correctly. So when you take the antiderivative, then you're going to get the value of 3 minus 2 cosine at -1, and then the value of the second piece of the piecewise function. And to get the average value, you're going to take that value and divide it by 2 because it's integral over interval. So you end up with this lovely expression, and you get 1 point for the correct answer. Phew! So now score yourself on this second FRQ. Be ruthless. What was your score? Okay. And then again, what were your weaknesses or mistakes? Great job. We've done 3 of the types now.